Hello everyone, I am Disha Moik, roll number 4046. Today I am here to present my essay activity 1 on the topic Distributed System Design Goals with Boolean Election Algorithm. So first, let us understand what is a distributed system. A distributed system is a collection of independent computers or a process that communicate with each other through a network. These computers are physically separated, but they work together to perform a common task or provide a common services. For example, when we use an online banking application, different servers may handle login, account information, and transaction. All these systems communicate with each other, but for us, it will appear as a one banking service. Similarly, cloud computing and distributed database are also examples of the distributed system. So the main idea of distributed system is that multiple computers works together to provide a single or common service. So the next is distributed system design goals. So first is the transparency. Transparency means hiding the internal complexity of the distributed system from the users. For example, when we upload a file to a Google Drive, we do not need to know which particular server or data center is storing our file. The system handles these details automatically. So the transparency makes the distributed system easier for the user to use. The second one is scalability. Scalability means that the system should be able to handle an increase in users' data or resources. For example, suppose a website initially has 1,000 users. Later, if the number of users increases to 1 million, the system should still be able to handle those users efficiently. This ability is called as a scalability. The third is reliability, which means that the system should continue providing correct services even if the some components have problem. For example, in an online shopping system, if one server has a problem, another available server should continue handling custom requests. Fourth one is the performance, which means that the system should respond quickly and uses its resources efficiently. So when we search for something on website, we accept the result should appear quickly. So a well-designed distributed system should provide a fast response even when many users are using it. So fifth one is the security, which means that protecting our data, users, and the communication from the unauthorized access. So in a online banking, our account details and the transaction must be protected using authentication and the secure communication. The last one is the fault tolerance. Fault tolerance means that the system should continue working even if one or more component fails. For example, in a one server, in a distributed system crashes, another server can continue providing the services. So the failure of the one component should not bring down the complete system. So these design goals help us to build the distributed systems that are reliable, scalable, secure, and able to handle the failures. Uh, now, one important problem in distributed system is what happens when the coordinator or leader fails. So the next point is why is leader election needed? So in a distributed system, sometimes one process is selected as a coordinator or leader. The coordinator is responsible for coordinating certain activities between the other processes. For example, suppose 5 computers are working together and one computer is selected as a coordinator. It may be responsible for managing the computer operation or coordinating communication. But what happens if this coordinator suddenly fails? The other process needs to select another active process to take its place. The process of selecting a new coordinator is called as a leader elections. There are the different leader election algorithms, and one of the important algorithm is the Boolean election algorithm. So now let us understand how Boolean election algorithm selects the new coordinator. So the Boolean algorithm is a leader election algorithm used in distributed system. In this algorithm, every process has a unique ID. The main rule is very simple. The process with the highest ID amongst the active process becomes the coordinator. When a process detects the current coordinator has failed, it starts the election. It sends an election message to all processes that have a higher ID. If the higher ID process is active, it will respond and continue this election. This process continues until no higher ID active process is available. Finally, the highest ID active process becomes the new coordinator and perform the other processes. So the next point is so let us understand the Boolean algorithm with step-by-step sequence. We will understand this by having a complete structure of an example. So suppose we have a 5 processes P1, P2, P3, P4 and P5. Their IDs are 1, 2 to 5. Initially P5 is a coordinator. So first suppose P5 fails. So which is the current coordinator suddenly fails, the other process can detect that the P5 is no longer responding. So the P2 starts the election. Suppose the P2 detects the failure of P5. It will start the election. P2 sends an election message to the all processes having a ID, higher IDs than the P2. So the P2 will send message to P3, P4 and P5. P3 and P4 are alive, so they will respond to the P2. But P5 does not respond because P5 has failed. This tells P2 that higher ID active processes are available. So therefore P2 itself cannot become an coordinator. Now the higher ID process continues the election. P3 and P4 are candidate because they have the higher IDs than P2. Since P2 has a higher ID than P3, P4, since P4 has a higher ID than P3, P4 has a higher priority. Now the P4 is now check the highest active processes. P4 sends the election message to the P5, but P5 has already failed. So the P4 does not receive any response. Since there is a no response from a processes with higher IDs than P4, P4 will become the new coordinator and declare itself as the new leader or the new coordinator. So the finally we will get our coordinator message to, and finally P4 will send the coordinator message to the all active processes and inform that the P4 is now new coordinator. So this is the whole structure we have seen. Now the message flow. So first the election message, it sends when it sends when a process detects coordinator failures and wants to start or continue an election. Then the OK, when a higher ID process receives the election message and it is active, it responds with the OK message. The third one is a coordinator message. After the election is completed, the winning process sends this message to the inform all other process that it is now the coordinator. So basically the flow is like election, OK, election and coordinator. So the next point is the advantages and disadvantages. The Bully algorithm has several advantages. So first, it is a simple to understand and implement. Second, it selects the highest ID active process as a coordinator. Third, it does not require a permanent central election server. And the fourth one is it works well when the process ID are unique and known. However, the disadvantages are it also has some disadvantages. First, it can generate many messages during the election. Secondly, if the process failure happens frequently, election may also happen frequently. Third one is the process needs information about the other processes, especially higher ID processes. So therefore, the algorithm is simple, but it can have a communication overhead. So let us compare design goals versus the Bully algorithm. So now, Bully algorithm with the design goals of the distributed system, it supports the reliability because when the coordinator fails, another active processes can take its place. Secondly, it supports the fault tolerance because the system are continue operating even after the coordinator fails. The third one is it provides coordination by selecting one process as a new leader. However, there is a no performance cost. The election requires message to exchange between the process, which continues communication overhead. As the number of processes increases, the number of message can also increases. Therefore, the Bully algorithm provides good fault tolerance and coordination, but it can increase communication overhead, as I said earlier. So now coming to the conclusion. To conclude, a distributed system consists of a multiple networks that works together through a network. The main design goals are transparency, scalability, reliability, performance, security, and fault tolerance. Then when a coordinator fails, a new coordinator needs to be selected. There is where there where the Bully election algorithm is useful. The main rule of the Bully algorithm is that the highest ID active process becomes the new coordinator. So in our example, P5 was initially the coordinator. When P5 failed, the election process started and P4 becomes the new coordinator because P4 has the highest ID. The algorithm is then we get to know that the algorithm is simple and effective, but it can be but it can generate the additional network traffic during the election. So the overall, the Bully algorithm helps maintain coordination and fault tolerance in a distributed system. Thank you.